how do we integrate sine squared of x times cosine squared of x? If we had an odd power of sine or an odd power of cosine, like sine cubed for example, then we could take out a factor of sine and the rest, sine squared, we could replace with 1 minus cosine squared, and we could do a u substitution with u equal to cosine. The du would take care of this extra factor of sine and everything would work out nicely. But because both of these are even powers, it's a little bit messier. We're going to need the power reducing formulas for sine and cosine, which are given here. Sine squared of x is equal to 1 minus cosine of 2x, doubling that angle, divided by 2, and a similar formula for cosine, but with addition instead of subtraction. Applying these formulas right away, we're able to rewrite the integral of sine squared times cosine squared as the integral of 1 minus cosine of 2x over 2 multiplied by 1 plus cosine of 2x over 2. And then we simply have to multiply these two things together. The half and the half can come out of the integral as a fourth. 1 minus cosine 2x times 1 plus cosine 2x, you might recognize that as a difference of squares factorization. When we multiply them together, the middle terms will cancel out, and we'll actually just be left with 1 minus cosine squared of 2x. Now we will again apply this power reducing formula, but this time we're applying it to cosine squared of 2x. Again, you've got to double the angle inside the cosine, so now we're going to have cosine of 4x. This is the identity applied to cosine squared of 2x. It's 1 plus cosine of 2 times the angle, so 2 times 2x, all over 2. And that gets us to this. We can integrate the 1, that just becomes x, and we'll multiply that by a fourth. And then minus a fourth times the integral of cosine squared of 2x. Cosine squared of 2x, of course, is equal to 1 plus cosine of 4x, doubling that inner angle, and it's divided by 2. Again, all we did here was integrate the 1 and hit it with that fourth, so it's a fourth x, and then that just leaves minus a fourth times the integral of the cosine squared. But by applying this identity, it's equal to that. Now we can finish up the integration. We still have the 1/4 x minus a fourth times the integral, and this is the integral of 1 plus cosine 4x over 2. There's two things we need to integrate here. The 1 over 2, that's just a half, and that integrates to a half x. And then we have the cosine 4x over 2. To integrate that, the cosine goes up to a sine, but then because the inner function is 4x, we got to make sure we divide by the derivative of that. Got to undo the multiplication by 4 that would result from the chain rule if we were to take the derivative. That's why we divide by 4. And of course, we still have that factor of 2 in the denominator. You can see if we took the derivative of this, we'd get the 1/2, and then with this expression, we would get cosine of 4x times 4 because of the chain rule. The times 4 would cancel out with this 4 in the denominator, and so we'd just be left with 1/2 plus cosine of 4x over 2. So this works, and we're also adding our arbitrary constant. Now we just have to simplify. Distributing this negative 1/4, the 1/2 x becomes minus an 1/8 x, and sine of 4x over 8 becomes minus sine of 4x over 32. Now we can combine the 1/4 x and the minus 8th x. 1/4 x is the same as 2/8 x, so this just simplifies to an 1/8 x, and then minus sine of 4x over 32 plus c. And if you want, you can combine the 1/8 x and the minus sine of 4x over 32 into a single fraction by multiplying the 1/8 x by 4 over 4. Then it becomes 4x over 32, and we can just write it as a single fraction. 4x minus sine of 4x over 32 plus c. And that's the integral of sine squared x times cosine squared x. You just got to be good at using those power-reducing formulas. Check out my Calculus 2 exercises playlist in the description for more. Thanks for watching, and let me know in the comments if you have any questions. Persistence, couldn't even open myself up for an instant. Was the law, it was regular, I regular.
aesthetic from my own efforgy. I didn't try just to be regular.